First of all, I'd like to thank the organizing committee for the invitation to take part in this conference. In this presentation, the following subjects will be considered. Self-assembly in mixed surfactant polymer systems and their application in different fields, including DNA complexation, LBL strategy, and encapsulation of a variety of substrates, including anti-inflammatory drugs and reactivator of acetylcholine esterase. Currently, in our laboratory, a homological series of amphiphilic compounds are designed and studied with a wide variation of the structure of head groups, amongst them monocationic and dicationic analogs with cyclic, microcyclic, bicyclic, and macrocyclic fragments. This allowed us to reveal the structure-activity correlations in self-assembling properties and functional activity exemplified by solubilizing, antimicrobial, and catalytic properties. Polymers are represented by blocks of polymers, fluoronics and synperonics, and polyelectrolytes, polyacrylic acid, polysulfate, polystyrene sulfates, DNA, bovine serum albumin, and their cationic analogs, polyethylenamine and chitosan. In addition to mixed surfactant polymer systems, covalent strategy is also used in our studies, which is exemplified here by the conjugates of 3-phenylphosphonium cation with polyethylenamine and chitosan. These conjugates are used in our study to review the colocalization of nanocarriers with mitochondria. This slide demonstrates the self-assembly study in binary systems based on polyacrylic acid and two types of Geminis, 16x16, and its hydroxyethylated analogs. These data were obtained under spontaneous conditions in which pH values ranged between 2 and 4.7. At this condition, a very low charge density was observed in polyacrylic acid systems. The self-assembly properties of these systems were studied by a variety of methods, including tensiometry, conductometry, fluorimetry, dynamic light scattering, and so on. As can be seen from tensiometry data, only one breakpoint was observed, and unlike with typical cationic surfactants, and no decrease in the critical aggregation concentration was observed as compared to single surfactant solutions. Critical aggregation concentration increases with an increase in polymer concentration. According to mining theory, such a low value of charge density of about 8% indicates that hydrophobic interactions mainly contribute to the complexation. However, the visualization of samples, tubidimetry, and zeta potential data testify that electrostatic interactions also contribute to the complexation. For example, the recharging occurs in the systems with an increase in the concentration that is transition from negative to positive zeta potential values. Therefore, despite the long, despite the low charge density, electrostatic interaction play a considerable role in this system. Along with synthetic polymers, the natural analogs are also used in our studies, which is exemplified here by the mixed systems based on woven serum albumin and homological series of cationic surfactants, mainly with imidazolium head groups. As can be seen from tensiometry data, in this case, 2 breakpoints are observed, unlike with the previous slide, and critical aggregation concentration markedly decreases as compared to single surfactant solution. The most pronounced decrease was observed in the case of highest analog, and the maximum 50-fold decrease was observed in critical aggregation concentration. The complexation in the systems was studied by a variety of methods, including dynamic light scattering, zeta potential measurements, electronic microscopy, different fluorescence techniques, and circle dichroism. Synchronic fluorescence techniques data testified that mainly tryptophan fragments contributed to the complexation in most cases studied, with the exclusion of methoxyphenyl derivatives of imidazolium surfactants, for which the contribution of tyrosine moieties was observed. It was shown that different interactions contribute to the complexation, including electrostatic interactions, hydrogen bonds, hydrophobic effects, depending on the structure of cationic surfactants. It was previously shown that in the case of typical cationic surfactants, ethyl-trimethylammonium bromide, the denaturation was observed in the systems. However, by contrast, no denaturation was observed in the case of imidazolium surfactants. The data of circle dichroism demonstrated that some decrease in alpha helix structure and increase in beta structures was observed with the transition from BSA systems to mixed compositions. One more direction of our investigations focuses on the DNA cationic surfactant interactions. It is known that cationic surfactants, due to its positive charge, can effectively interact with phosphate backbones of DNA. And in our studies was documented that transfection efficiency can be markedly affected by the structure of cationic surfactant. This is exemplified here by the two types of Gemini, S16 and their hydroxyethylated analog with different spacer fragments, different spacer lengths. As can be seen in the case of unsubstituted Gemini, rather low transfection efficiency was observed. However, this parameter markedly increases with the introduction of hydroxyethyl fragment, and a maximum effect, highest effect, was observed in the case of Gemini with longer spacers. It can be explained at two reasons. First, the turbidimetry data demonstrated that only in the case of leader compounds, effective integration with lipid bilayer was observed, unlike with other GMNs. And second, it can be assumed that probably long spacers can provide conditions for the effective complementary interactions between the positively charged nitrogen atoms and phosphatenines of DNA. These results encouraged us to study the DNA surfactant concentration with the systematic operation of the structure of cationic surfactants, which for this homological series of imidazolium surfactants were used with methyl, hydroxyethyl, and carbamide substituents. And the complexation was studied by different methods, including electrophoretic light scattering, gel electrophoresis, ethidium bromide quenching assay, and flow cytometry. As can be seen from the potential data, only in the case of carbamide derivatives, typical behavior was observed, and recharging occurs in the systems with an increase in the surfactant DNA molar ratio. By contrast, no recharging was observed in the case of other imidazolium surfactant. This result are in line with the data of gel electrophoresis, which demonstrated that no complexation was occurs in the case of this series, unlike with typical cationic surfactants, acetylmethylammonium bromide. At the same time, ethidium bromide exclusion study testified that effective binding between the component take place. And this result are supported by the flow cytometry study, which shows that a marked increase in the fluorescence intensity was observed in the presence of surfactant DNA complexes. Drug delivery systems based on amphiphilic compounds and polymers received much attention due to their biocompatibility, low toxicity, protection effect from the biodegradation, and providing condition for the prolonged circulation and targeted delivery. This slide demonstrates some of nanocontainers developed in our work, included micelles, microemulsions, polyelectrolyte capsules, liposomes, chitosomes, transversomes, including neosomes, solid lipid nanoparticle, and mesoporous materials. It should be emphasized that one of the main tasks which is solved in these studies is the construction of nanocarriers for the overcoming the blood-brain barrier, and the first of biological barrier, and first of all blood-brain barrier and skin barrier. One of the very attractive techniques for the construction of drug delivery systems is the layer by layer strategy, which involves the alternative deposition of oppositely sides polyelectrolyte, oppositely charged polyelectrolyte lattice, and usually a sacrificial template is used for this purpose. To date, diversity of modification of this strategy is documented, and in our work, a simple LBL protocol was developed with no sacrificial template used. According to this protocol, first polyelectrode layer was deposited directly on the substrate dispersion, and to enhance the interaction, substrate can be treated with, for example, cation surfactants, and in this case, the negatively charged first layer should be used, for example, polyacrylic acid. I'd like to emphasize that the use of this protocol without sacrificial template allowed us to transfer from micro-sized diapason to nano-sized particles with about 20 to about 100 to 200 nanometers. This protocol was used for the encapsulation of different substrates, including anti-inflammatory drug intimidation, carbon and phosphorus acid esters, fluorescence probe iron, and so on. In these studies, factors controlling the properties of the capsules were determined, and it was shown that one of the main factors is pH failure. As can be seen, the optimization of the systems in terms of pH make it possible to obtain monodisperse nanoparticles with low polydispersion index. Important parameter of the capsules is release profiles, and it was shown that main factors controlling this parameter are the pH value, especially in the case of such polyelectrolytes as polyethylenamine and polyacrylic acid, as they are pH dependent. The number of layers and the treatment, ultrasonic treatment of the systems. As can be seen, in this case, the variation of these factors can markedly change the time of release. Now, one of the main direction in our studies is the development of the drug delivery systems for the acetylcholine esterase reactivator. It is known that acetylcholine esterase is an enzyme that catalyzes the breakdown of acetylcholine. Organophosphate can inhibit this enzyme by phosphorylating the serine hydroxyl residue on active center. The gold standard for the acetylcholine esterase reactivators are AXIM, but one of the main problems associated with AXIM therapy of organophosphate poisoning is the inability to cross the blood-brain barrier. This slide demonstrates our recent results in which the liposomes decorated with chitosan were for the first time used for intranasal administration and delivery of AXIMs to the brain. In this study, different modifications of chitosan were used, including high molecular weight, low molecular weight chitosan, and its arginine derivative. And before the in vivo test, these nanocarriers were optimized in composition and characterized by different methods, including dynamic and electrophoretic light scattering, electronic microscopy, and others. It was shown that deposition of chitosan on liposomes resulted in recharging in the systems and transition from negative zeta potential value to positive of about 25-30 millivolt. Importantly, that transition from liposome to chitosome is accompanied by an considerable increase in the loading capacity of about by 20%. For all formulations, release profiles were obtained in vitro and ex vivo experiments, and it is shown that for all formulations, a prolonged release was observed compared to free oxime, while the type of chitosan and its concentration little influence the time of release. Reactivation efficiency was tested in vivo with the use of a model of peroxone-induced poisoning on several groups of rats after the intranasal administration of oxime. And it was shown that the type of formulations markedly affected the reactivation efficiency, and the most promising results were obtained in the case of formulation with arginine derivatives. For this formulation, a high degree of reactivation of about 35 was obtained. In many cases, drug delivery systems need to show the gel-like behavior, especially, for example, in the wound healing therapy or trans delivery of drugs. And therefore, this slide show two examples of such formulations. For example, the ML gel were constructed based on the microemulsion loaded with abietic acid and modified with carbamide surfactant. Abietic acid is biological compounds with a combination of biological activity, including anti-inflammatory, antimicrobial, and antioxidant activities. And carbamide surfactant was used to stabilize the systems and enhance the antimicrobial effect. It was shown that transition from microemulsion to ML gel is accompanied by a marked decrease, considerable decrease of viscosity by several orders of magnitudes, and modification of release profile. As can be seen, sustained release was observed in the case of ML gel as compared to microemulsion formulations. Such in vivo tests demonstrated that such a beneficial combination of physical properties and biological activity made it possible to develop highly effective formulations for the wound healing therapy. This strategy was further extrapolated for the solution of rather challenging tasks of construction of drug delivery systems for oxime therapy, for the transdermal oxime therapy. For this purpose, according to the algorithm developed, on the initial state, transversomes were prepared, which are suitable for the transdermal delivery. These transversomes were modified with pyrrolidinium surfactants for the enhancing their affinity to biological membrane and biological barrier. Liposomes loaded with VAPAM were then embedded to the carbapol gel and tested in vivo. In this case, the same protocol, namely a model of peroxone-induced poisoning was applied, and it was shown that prophylactic intranasal administration of oxime-loaded gel in combination with post-exposure therapy resulted in the marked increase in the survival rate rates from 55 to 90%. This is rather promising results which was obtained for the first time in our investigations. To conclude my presentation, I'd like to thank my colleagues who take part in this study, and first of all, my colleagues from Laboratory of Highly Organized Matter. And thank Russian Science Foundation for the financial support and Lipoid Company for the supporting of our investigation. Thank you very much for your kind attention.